Hi, we're starting our notes about circles, so this is on page 114. We're going to do some definitions to begin with. A circle is a set of points equal distance from a given point. That given point is the center. So over here, if this is the center, all the points that are equal distance from that point is what we would call circle P. A radius is from the center to any point on the circle. So a radius would be like from here to drawing that to any point on the circle, and that's my radius. A chord is a segment with endpoints on the circle. Line segment. Endpoints are on the circle. So again, you can start anywhere. Now, it doesn't have to go through the center. If it goes through the center, right here I would have a chord. So this diameter is still a chord, but it's a chord that goes through the center. Usually, if it is a point that goes through the center, it's noted with an actual dot. Otherwise, you would just draw through without having an actual point in there. The endpoints are dots and the actual radius, but you wouldn't have a point on the line. If you have an actual point, that is considered the center. So that would be the center of the circle P. This would be diameter AB, let's say. This over here, we can name this. Again, I'm just making these letters up. Let's say we name this JK. That would be my endpoints of the chord. Now, a secant is a line that goes through the circle. So again, does not have to be the center. It could be the center, but it doesn't have to be the center. So if I were to draw here a line, up here there are chords, they end on the actual edge of the circle. Here this is a line that goes through it. It could still have points on the circle. Let's say we call this Y and X. But it doesn't end there, it goes on forever. Tangent is similar to that. Tangent is a line that intersects it at exactly one place. I always think tangent, touch. Line intersects circle at one place. At exactly one place. So a tangent would be something like this. Let's say we have a line that goes on, does not go through the circle, it touches it right here at one spot. Let's call that R. And the rest of this could be a line, points P and A. So it goes on, but there's one point on the circle that it goes through. Point of tangency would just be this actual point. So let's say this is T. T would be the point of tangency, where the line is tangent at. Point where a line is tangent. We're on the next page. Central angle is going to be an angle where you have a vertex from the center of a circle. So I'm going to draw a circle. From a circle, and the two sides are radii. So if we start at the center here, and we have two radii, so again, it doesn't go through. Here are two radii. Let's say this is A, let's say this is B, and this is our center, our circle P. Here is our central angle right here. Now an inscribed angle is where the vertex is on the circle. Two sides are chords. So here we're going to go, let's say we have a point on the circle here. It's a chord, doesn't go through. So let's say this is point A, this is point B. Now again, this isn't P, this is C, let's say. This is going to be an inscribed angle. It's inside, all the way inside the circle. Now an arc, let's say I have points here, A and B. An arc is going to be this length right here. So an arc is notated with like this curved kind of rainbow. What I would call this is I would say this is arc AB. You would put the arc above it like you would put the line segment bar above it earlier this year. So that's something I would call this. Now a minor arc is an arc with a measure that is less than 180 degrees. Whenever you have a minor arc, you will name it using two letters. So a minor arc would be like my AB up here. I would name this arc AB. Now, a major arc is going to be a little bit different. A major arc is going to be an arc that is greater than 180 degrees. Okay, now when you're naming a major arc, you are going to use three letters. The reason for this, because let's say we have A, B in the same spot here. Well, that's less than 180. You can tell that it's not a diameter, it doesn't go through the center. It's less than 180. Let's say we have point C over here. Now, I don't want you to go the short way from A to B. I want you to go the long way. So if you're ever naming an angle, you always go the shortest route unless they force you to go the longest route. And the only way they can force you to go the longer way is if they throw a third letter in there. So if I called this arc ACB, so you don't name it alphabetically, you name it in order from the first letter where you would have to go through to make it go the long way. Otherwise, you always go the shortest way unless they give you a third letter to go the longer way. Now a semicircle. An arc where the endpoints are on the diameter. It is exactly equal to 180 degrees. And because it's not less than 180, you have to use 3 letters. So you know whether or not you're going on the top part or the lower part. So again, this one is equal to 180. So let's say we have a center here. And I tell you this point over here is J, this point over here is L. If I tell you to name the semicircle, how do you know if you name it JL up top or JL down below? You don't really know. I have to give you a way. So if there is a third letter, I could say JKL, and that forces you to go the direction I wanted you to go. Formulas, if you remember any of these formulas, go ahead and write them down. Area of a circle equals pi r squared. Circumference of a circle equals 2 pi r, or you can do pi times diameter. Now, arc length of a circle, remember we were doing those arc lengths the other day? You set up a proportion. Length goes on top because length is the circumference on bottom. The degree of the part on top over the entire degree on bottom. There you go. I'm going to pause. We are going to go on to 10-1 notes though, but I wanted to finish those vocab words first. So this is fun on page 116. I am going to quiz you. I want you to go through here. You have to pick these. You can use some of them more than once, I believe. Maybe not. But I don't think there's a problem. You can probably use, parts may be used more than once. Use these definitions. Name what they're talking about. 1 through 19 odds. I'm going to give you the answer to the odds right now. I'm probably going to come back in class and have you guys do the evens over here. So we're doing the odds right now. I'm going to pause and I'm going to fill in all my answers. So you pause, fill in everything you know before you come back and see the answers. Pausing now. Now I'm not going to go through all of these, the names one at a time. You should come back and check them, make sure you understand where they came from. If you don't know where they came from, make sure you come to class and ask questions. So, hopefully you guys watched this already or filled it in. Tangent, inscribed angle, major arc, radius, minor arc, point of tangency, semicircle, chord, minor arc, radius. Good job. Did you get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10? Did you get like at least 8 out of 10? Would be pretty good. Okay, I'm going to pause and go to the next page. We'll probably come back and do the evens in class. Okay, pause and fill in these formulas on your own. Do you have them memorized? And we just wrote them down on the other page. Hopefully you have them memorized. Area of a circle is going to be pi r squared. Circumference of a circle is 2 pi r, and 2 radii is equal to pi times diameter. So right here, find the area for the circles and circumference for circles 5 through 8. So 1 through 4 is area. Five through 8 is going to be circumference. Pause, do these all on your own. Okay, area, I write the formula each time probably. Area equals pi r squared. I'm going to get 144. I'm going to leave pi in my answer, pi meters squared. That's a better way to write it. I believe that's how you're going to be asked to do it most of the time. If you did it as a calculator, you should get approximately 452.39. I'm going to do all the odds. Area here is going to be pi 2.8 squared. So when I square that, I get 7.84 pi feet squared. Again, this is my preferred answers. But if you plug in pi, the pi symbol, you should get 24.63. Okay, next one is going to be circumference, so it's 2 pi r. I get 14 pi, which is approximately 43.98. Again, pause, I'm going pretty fast. Circumference here is 2 pi r. Well, the radius is not given. Half of that would be the radius, so it would be 29. Circumference is equal to 2 pi 29, which means it's going to be equal to 58 pi. And that is yards. So these units down here are just single units. The units up above are different because they are area squared. Okay, I'm going to pause and just do the answers to the other side so you can come back and check. Before we get too far ahead of ourselves, just for like sake of ugly numbers, I'm going to make this number instead of 35 and instead of 115.6, I'm going to make this number 30, and I'm just going to make this one 15. So go ahead and keep it as 15. 10.2, that's actually not too bad, so we'll do that. Okay, I'm going to pause and come back with the answers. Here are the answers to the evens. 81 pi, 225 pi, 30 pi, if I made some adjustments here, again. 10.2 pi. We're going to go to the next page, and I'm only going to do a few of these on the next page. Let's go ahead and do 11, if you want to pause and set that up. And then 15, 16. So find the radius of a circle with a circumference. Well, if I know circumference equals 2 pi r, and the actual circumference is 35 pi, I'm going to divide both sides by 2 pi. Well, the pi's are going to cancel. R is going to be equal to 35 over 2, which is 17.5. And again, circumference is just single units. It's going to be yards. Okay, next I want to go ahead and do these ones. Find the area of a circle with a circumference of 26 pi feet. So again, I know that the circumference is equal to 26 pi, which is equal to 2 pi r. And I want to find the area. So for area, I need pi r squared. I need to solve for r. I'm going to divide both sides by 2 pi. I'm going to end up with r equals 13. Okay, so that's step number 1. Once I know what r equals, because that's what I need, I'm going to plug it in here. Squared, I get that my area is 169 pi feet squared. Okay, go ahead and try that on number 16. This will be our last one. Circumference of a circle with an area, so pi r squared equals 289 pi. And divide both sides by pi. Then I'm going to take x squared equals 289. I'm going to plug that in my calculator. Can I square root that? Second square root 289, and it is exactly 17. So once I know it is 17, and I want to find the circumference of a circle, if the area is that, circumference is going to be 2 pi r. And I'm going to plug the 17 in there. I end up with 34 pi millimeters. Over here, it's millimeters squared. And there we go. So that is it for the notes 10-1. Good luck, and I will see you next time.